Hello, students. Welcome to Calculus in 10 minutes or less. Today, we are going to review the quotient rule. We are going to cover the example from OpenStax Calculus, Volume 1, Section 3.3, Example 3.25, applying the quotient rule. We are going to use the quotient rule to find the derivative of this following function named k. We will use the rule stated above, and I have highlighted in red that subtraction symbol in the middle of those two terms in the numerator. That subtraction term is very important. We will see why in this example. I remind you as well that the derivative of the quotient of two functions, f of x divided by g of x, requiring in this case that f be named the function in the numerator and g be named the function in the denominator, is equal to g times f prime minus f times g prime over the square of g. I like to think of this when I'm writing it down without the formula sitting in front of me, that I have to write the denominator first in the numerator when I apply the quotient rule, then multiply it by f prime, but I need to then subtract f times g prime. And remember, when you subtract, order matters. These two things subtracted in the other order are not equivalent to what you see here. So we need to make sure when we are applying the quotient rule that we write the denominator first. You may have heard the expression low d high minus high d low. The d in that little mantra means derivative. So take the low function and multiply it by the derivative of the high function, and then subtract the high function and multiply it by the derivative of the low function. Just don't forget to divide that all by g squared. So here, I again encourage you to rewrite your derivative rule every time you need it. And in this case, we are finding k prime by differentiating the expression k, 5x squared divided by 4x plus 3. And again, just like before, I highly encourage that you identify f and g and write them down, even for these more quote unquote basic examples, because as we get more advanced and we see in a little while combining derivative rules, these get more complicated. So write down your function f, make sure you pick the function in the numerator, and write down your function g, make sure you pick the function in the denominator, and then differentiate them. The derivative of 5x squared is 10x, and the derivative of 4x plus 3 is 4. Go back and review your power rule if you need to at this stage, especially if you're looking at this and saying, I don't know why that's the derivative of 5x squared, or I don't know why that's the derivative of 4x plus 3. That's because of the power rule. And at this stage, if you're not comfortable with the power rule, you're not using your time wisely. So I have these written down, and now I just need to pick up the blue function and place it in my formula where I see the blue function. Likewise, for the green function, pick up the green function and place it in the spot where I see the green function, etc. So this derivative is low or green, 4x plus 3, times d high or f prime, and then minus, I'll continue writing this in red to really emphasize if you do not subtract the entire expression f times g prime, you will get the incorrect answer. So f is 5x squared and g prime is 4. And then don't forget, we're dividing that all by the square of the denominator. I personally actually usually like to write this first because it gets something on my paper that is correct. Now, simplify the numerator. 4x times 10x, 3 times 10x. That's 40x squared plus 30x. And then I need to subtract the expression 5x squared times 4. And again, divide that all by the square of the green function. So here we have 40x squared plus 30x minus 20x squared, all divided by 4x plus 3 squared. That's 40x squared minus 20x squared, or 20x squared, plus 30x divided by 4x plus 3. squared. Now, you can FOIL out the denominator here. You can also take out an x from the two terms. Actually, you can take out a 10x from the two terms in the numerator. But for sake of simplicity, for now, we are going to leave the denominator as is. Squaring that out right now doesn't necessarily lead us to a simplification. In fact, more often than not, you're going to miss a simplification if you FOIL. So I encourage my Calculus 1 students to leave denominators unsimplified until you're sure that you have no other option but to simplify. In this case, we're okay. We don't need to simplify it. We have the solution to our derivative that we were asked for here, and we are done.